Welcome to the review video for pre-algebra. Okay, these are the chapters we chose this year. So it's going to be turn this into a fraction. Now, because of the 5 is this is a repeated decimal and has the line above it, so it means it's 0.555555555 forever. So what we're going to be doing here is we're going to be turning this into a fraction. So first, you make x equals 0.5 to infinity. Now, there's only one number repeating forever. It's just a 5 repeating forever. So we're going to multiply both sides by 10. So 10x equals 5.5 forever. Because you multiply by 10, it's just going to move this, shift this over 1. And then you got to remember that there's still 5s going on forever. So it's not 5.0. There's a 5 here. And another one, and another one, and another one. So that's why when I shifted it over, it's still 5.5. Then we're going to subtract everything that's up here from down here. So subtract 1. So subtract x and subtract 0.5 forever. So this will give me 9x, and this will give me just 5, because I'm subtracting a 0.5 forever from here, from the 5's forever. So these 5's forever are going to end up not here anymore. So now it's just this, divide by 9 to keep the x by itself. And here's our fraction, 5/9. Now we're going to do the same thing over here. Again, the 6 is the only number repeating forever. So what we're going to do is multiply both sides by 10. So x equals 0.26 forever. And this is going to multiply by 10. So now we're left with 10x equals 2.6 forever. We are going to subtract by x, leave us with 9x. And we're going to subtract by 0.26. Now there's a number missing here, so I have to add another 6. Because remember, the 6's are going forever. So this is going to be the 6's forever minus the 6's forever. These are gone. That's going to become a 4. This is going to become a 2. So 2.4, 9, 9. So now x equals 2.4/9. Now, you can't leave it like that because you're not allowed to have decimal points in a fraction. So this is going to be 24/90. I multiply both by 10. Now I can cut them both in half. 12/45. They're still divisible by 3. I'm going to get 4/15, and I think we are done. Now we're going to do this one, 2.09. Now, because it's 2 and a decimal point, you know that's going to end up to be 2 and a fraction. So we're going to ignore the 2. It's already there. Now we're going to deal with a 0.09. So x equals 0.09. And the 0.9 is repeating forever. So 0 and 9, which means I'm going to multiply over here by something with 2 zeros because there's 2 numbers repeating. So now we're going to multiply this side by 100 and this side by 100. Leaves with 9.09 forever. Then we're going to subtract an x, subtract a 0.09 forever. We're going to be left with 99x equals 9. Divide by 99, divide by 99. These are obviously both divisible by 9, so we get 1/11. Okay, that's the pattern for which we do this. Now we're going to slide this up and do this. So 100 equals s squared. So something times itself equals 100. Okay, so if you were solving this and you were trying to do it in a calculator, you would do the square root of this side equals the square root of this side. Now, a square root and a square are opposites, so they cancel each other. So now you're just left with s. Now, the square root of 10 is what number times itself equals 100. So that's going to be 10. 10 times itself will equal 100. What about 343? Okay, what's the cube root of 343? Okay, we're going to have to do the cube root of it, and that would cancel each other, and the cube root of it, and that would cancel. What you're looking for is a number times itself again, that will give you 343. Now we know that 10 is too much. 10 times 10 times 10 is 1,000. So we know it's less than 10. We know it's odd because it ends in an odd number. So it could be 9, it could be 7, it could be 5, it could be 3, it could be 1. It's not 1, it's not 5 because of the way it ends, and it's definitely not a 1. So let's go for another guess. So let's try 7. 7 times 7 is 49. 7 times 7 is 49. 49 times 7 gives me 343. So that's right. So it's going to be 7. This is the right answer. Okay? What about 50? Well, I don't know the answer. I know 7 times 7 is 49, and 8 times 8 is 64, so 50 is somewhere in between. If that happens, okay, remember how we solve it. The square root cancels, the square root of 50. If you do not know the answer is square root of 50, then the answer is just the square root of 50. It's an irrational number. There's no way you're going to write the actual answer here, so that's what you do here. All right, let's talk about this. Okay, so what is 3 to the power of 0? Any number to the power of 0 is 1. Okay? Any number to the power of 0 is 1, except for 0. 0 to the power of 0 is 0. Why? Because anything to the power of 0 is the number divided by itself. That's why 0 makes 0. But any other number, like 5 divided by 5, is going to make 1. What about this? When numbers divide that have exponents and they have the same base, the exponents are going to subtract. So it's going to be 3 minus 5 is going to be the end result. So it's going to be 4 to the power of 3 minus 5, which is 4 to the power of negative 2. 4 to the power of negative 2 can also be written as 1 and 4 to the power of 2. You see how the negative sign is telling you, hey, I'm on the wrong side of the fraction. And once you put it on the correct side of the fraction, it's positive. So here, if I wanted to write this with no negatives, I would just write 1 and 8 to the second power. If I wanted to write this with no negatives, all I would do is shift it to the top of the fraction. So it would be 7 to the power of 3. And there's only a 1 left down here. When you move something from a fraction, it becomes a 1. Okay? All right, next one is this one. Okay. So we're adding things scientific notation. Okay? You cannot add or subtract any scientific notation unless these are the same. So what I'm going to do is shift it 2 more times. So this is not going to change at all. It's still going to be 5.97 times 10 to the 20. But now I'm adding with, after I shift this twice, it's going to be 0.0735. So 0.0735 times 10 to the power of 20, because I shifted it twice, so 2 more times would make it 20. So there you go. There's our number. So now we add. We're going to have a 5, a 3, a 14, a 0, a 1, a 6. 6.0435 times 10 to the 20. Nothing happens to the exponent after you're done adding. Because you already did what you had to do. You had to shift it to make this larger. Things cannot add unless they're the same. Here, multiplying, no restrictions. These 2 first numbers are going to multiply just like you think they're supposed to. So it's going to be 8.2 times 4.3. This is going to make 6. This is going to make 24. That's going to make 8. And that's going to make 32. So we're left with 6, 2, 1, 5, 3. Don't know why I wrote a 2 there. 3. 2 numbers beyond the decimal point. So 2 numbers beyond the decimal point. So we're left with 35.26. And then times 10 to the power of, now when they multiply, they add the exponents, and they have the same base. So it's going to be 2 plus 1, which would give me 3. Now this would normally be correct, but this number cannot be it cannot be bigger than 10, and it cannot be smaller than 1. So I have to shift this over 1 extra time. 1 extra would shift this. So we're left with 3.526 times 10 to the 4th. Final answer. Now we're going to divide here. So when you divide, these numbers divide. So 1.83 divided by 3. So 1.83 divided by 3. That's going to leave me with 0.61. Sorry, not 3. So 0.61. Okay? 0.61. And remember, the exponents are going to subtract. So it's going to be 6 minus 1. So it's going to be times 10 to the 5th. The thing is, I have to go back 1, which makes this go back a number. So we're left with 6.1 times 10 to the 4th. Final answer. All right. Now we're shifting back down. We're left here with slope. So we're trying to figure out what the slope is here. There's two methods of doing this. The formula that they give you is y2 minus y1 divided by x2 minus x1. So you put these points that they gave you here and you'd plug it in here, okay? This is x, this is y, this is x, and this is y. So to separate them, you'll call this 1, 1, 2, 2. And then you would just plug them into here and subtract them. Another method of doing it is you just figure out how far it is. Now remember, y is on the top. So how did a 9 turn into an 8? Oh, it went up 9, so a positive 9 on the top. How did a 12 turn into a 24? Oh, it went up 12, so positive 12. If it would go down, I write a negative sign. Then this is going to be 9 over 12, so there's going to be, these are divisible by 3, so it's going to be 3 over 4. And there's your slope. Okay? I'm going to show you the other method here. I'm going to grab the 2 points from this graph. So it's 3, 3, 3, 3, and then 6, 5. Okay, 6, 5. I always say the x first and then the y. So 6, 5. Those are the 2 points. So I'm going to put them in here. Remember, this is x1, y1, x2, y2. So you put it in there. So you go, y2 goes first, so right here, 5 minus 3 divided by 6 minus 3. You're going to be left with 2 over 3, and there's your slope. Okay? If you would use the method we used above, it would have been the same thing. How did a 3 turn into a 5? It went up 2. How did a 3 turn into a 6? It went up 3. There's your slope. Same system. So that's how you find slope on a graph. You just have to know how far numbers are from other numbers. Pretty simple concept. So here we're going to graph. I'm going to graph one. I'm going to graph both lines on here. So please pay attention to which one's which. So this is the first one. This is your y-intercept, and this is your slope. That's all you need. The y-intercept tells you where you start on the y line. So it's going to say I start on 2. So there's my first dot, right on the 2 on the y. That's your y-intercept. Then 3 over 4 is how you find the next dot. So according to this, I have to rise 3 and then run 4. So from the dot that I already made, I'm going to rise 3, 1, 2, 3, and run 4. 1, 2, 3, 4. I'm going to end up right there. And there is my graphed line right there. Okay? Now let's try this one. This one starts on positive 1. This is your y-intercept, your start point. So it starts right here on the 1. Then it says the slope is negative. Negative 1 over 2. So negative means down. It doesn't change the 2, it changes the numerator. So it says down 1. So you're going to start here, you're going to go down 1, and you're going to go to the right 2. 1, 2. Okay? Now, Mr. Kaiser, does it have to be the top, has to be the negative? No, the negative doesn't belong to anybody. It's so easy to memorize that down is negative and up is positive. It's so easy to remember that. So that's why I think it's the best way. You could say, if you would have gone up 1 and over 2, you would have also made this exact same line. Okay, but it's just so much easier to remember to go down when you have a negative graph, a negative slope, and go up when it's positive. It's just so much easier. All right. Here we go. So here's what's going on here. This is the scenario where it's infinite solutions, one solution, or no solution. So memorize the situation here. If the slope is different, okay, if the slope is different, then there is one solution. Okay, one solution. If the slopes are different, it's one solution. If the slopes are the same, then you have one of these options here, infinity or 0. Okay, now infinite means everything's the same. Is everything the same? Nope. So it's got to be 0 solutions. Here, the slope is the same and the y-intercept is the same. Everything is exactly the same. Infinite solutions. Okay? Now here we're going to be solving for this equation right here. We're going to be solving for this equation. So this is we're using substitution. So we're going to substitute x with this formula right here. So this is going to be y plus 2 times, instead of x, I'm replacing with this. It's called substitution. I'm substituting these. So instead of x, I'm going to write 3y plus 5 equals 3. So now I'll distribute, and now we're left with y plus 6y plus 10 equals 3. Now I can combine the y's right here. So we're going to combine them, and we're going to get 7y, because there's 1y and 6y. So 7y plus 10 equals 3. Now I can solve it like a two-step equation. Subtract the 10, because it's the furthest from the y. 7y equals negative 7. Divide by 7. Divide by 7. Y equals negative 1. If y equals negative 1, I can plug it into the original problem, because x equals 3y plus 5. So if y is negative 1, it's going to be 3 times negative 1 plus 5. So that's going to be negative 3 plus 5 equals x. And that'll be x equals 2. Okay? All right, let's go to the next one. So for this one, I'm doing dilation. Okay? So dilation comes in two ways, multiplying and dividing. So we'll do the first one, which is going to be we're going to be dividing this. Okay? So let me see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 2, 2, 4. Okay, I know. So let's do a dilation of 1/2. Okay, which means every single number is going to be divided by 2. When you do a dilation of 1/2, the denominator is doing the dividing. Okay, so this point right here is 1, 2, 3, 4, 5, 6, 7, 8, 2. So this is 8, 2. So negative 8, positive 2. And we're dilating it by 1/2. So that means cuts everything in half. So instead of 8, it's negative 4. 1, 2, 3, 4. Instead of 2, it's 1. So we're looking for negative 4, 1. So 1, 2, 3, 4, 1. There's your new dot. Next, we'll look at this one. This is 2, 4. So this is 2, 4. Now I'm going to divide everything by 2. So I'm looking for 1, 2. Gotta cut this in half, and I cut this in half. So 1, 2 would be 1, 2 right here. Then this one is 4, 6. So 4, 6. So we're going to cut this in half. That'll make it 2. We're going to cut this in half. That'll be a 3. So now 2, 3. So 2, 3 right there. And this is your dilated triangle. A triangle that has been cut in half. It's half the size of the original. Now let's go to the next one then. Let's do a dilation where I multiply. Dilation of 2. Okay? So let's see what we got here. We have, this is a 2 by 2. So that's 2, 2. So if I dilate it by 2, meaning multiply by 2, it's going to be 4, 4, right? So 1, 2, 3, 4. 1, 2, 3, 4, right? There is the first dot. The second dot is 4, 2 again. So it's going to be 4, 2. We're going to turn it into 8, 4, right? We multiplied everything by 2. So 8, 4. So 1, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. Right there. So far we got that done. Now let's do this one. This one's 4, 4. So that's going to make 8, 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And there is my other triangle. So this is a dilation of 2. Multiplying all the dots by 2. Dilation means multiply. Dilation means things bigger or smaller. Now we're doing Pythagorean's theorem right here. This is going to be a squared plus b squared equals c squared. The hypotenuse, the longest side of the triangle, is the hypotenuse. It's going to be c in every scenario. If you can't find it, the 90-degree points at it. See how it's that one right there? Okay? It points at it. All right, so let's do this. So this is a squared. So any of these are a and any of these are b. But if you make this a, this one's b. If this one's a, that one's b. Okay, so I'll do 4 squared plus 3 squared. That's the ones on the left. C is the one over here all by itself. So it's got to be this one over here. So it's going to be 16 plus 9 equals x squared. This is going to make 25 equals x squared. How do we get rid of the squared? We square root. So the answer for this is 5 equals x. So that's that one. Now here, x is over here. But this is the hypotenuse. This is c. These are not. So I'm going to make x over here plus 6 squared equals 10 squared. So that's going to make x squared plus 36 equals 100. If I subtract 36 on both sides, x squared equals 64. Square root, canceled. X is now 8. Okay, so these are the only two scenarios you can get in Pythagorean's theorem. It's going to be this one or it's going to be that one. All right, so now we're looking here. So now these are the formula I've asked you to memorize. So we're just going to plug the numbers appropriately and then solve it. Okay, so this is going to be, I'm going to leave it in terms of pi, and then if you want to write in the comments what the final answer is, I'll be fine with that. So let's call this 1, 2, 3. Okay, and then the next one will be 4. So let's do this one. So 2 pi r, radius has been given. This is the radius from the center of the circle to the end. So it's going to be 2 times, well, we'll save pi for later. We're going to leave pi out of this right now. So 2 times 5 squared, right? And then that's going to be plus diameter. Now diameter is the whole length, so that's going to be 10. Because if 5 is halfway, then the whole thing is 10. And then pi we're skipping, and h is the height, so that's 6. So that's going to be 25 times 2, so that's 50, plus 60, that makes 110. And then we can put the pi at the end, 110 pi. If you can do the 110 times pi, you can tell me what the answer for number 1 is. Again, we're going to ignore pi until the last second, even for this one over here. Even for this one right here. Ignoring pi until the last second. So it's going to be just r squared. The radius is 4. And the slant height they didn't give us, so let's say it's 8. So 4 squared plus 4, because the radius is 4, and then the slant height is 8, so that's times 8. So 4 times 4 is 16, plus 4 times 8 is 32. So we're going to put that together and we're going to make 48. Okay, then we put pi in at the end. If you know what 48 times pi is, tell me what it is right here. Then we're going to be doing 4 pi r squared. So all you have to do is look for r squared. They gave me the diameter. So then I'm going to look for what would be half of this, 4. So it's going to be 4 times 4 squared. So 4 squared is 16. 16 times 4, 64. So 64, and then we insert that pi in the last second. Pi is in there. Now let's do one more circle formula, and we are done. So this is volume of a sphere. Volume of a sphere, again, we're going to ignore the pi until the last second. So it's going to be 4 times r, which is cubed, divided by 3. So r is 8. So 4 times 4 to the third power divided by 3. So 4 to the third power is 64. So 4 times 64 divided by 3. So 4 times 64 is going to be 256. So 256 divided by 3. And then we'll leave that like that for now because it's 256 divided by 3 pi. Okay? And then tell me what the final result for that one is. But that's the simplicity of this. For these kind of questions, you will get a calculator. All right, guys, that's it. Good luck.